Hi there and welcome once again to electrochemical lesson. We're looking at electrolytic cells in this lesson. And what is an electrolytic cell? Well, in an electrolytic cell, an electric current is introduced. An electric current is introduced into an electrolytic electrolyte solution. We already know what an electrolyte solution is. Okay, with electrodes, we know what electrodes are, to force a non-spontaneous reaction. Excellent. So in the previous few videos we looked at galvanic cells or voltaic cells, and in a voltaic cell we had a chemical reaction producing an electric current. This is completely the reverse. We're introducing electric current to produce a chemical reaction. So it's quite cool. I'll give you the basics of it. So what we're going to have is different than with the galvanic cell. We are going to have a single container, and in this container we are going to have a solution. Now in this solution I am going to have some cations and some anions. So we'll have some cations and some anions. Let's do it like this. Let's say, no, that's going to confuse us. Okay, let's say cations, they are the positively charged ions, and some anions. Okay, so it's an electrolytic solution. Electrolytic solution means a compound was dissolved into an aqueous solution that separated into ions. Now also what we will have in here is some conductive electrodes, too, and notice it all happens in the same container. Okay, so it's not like in the voltaic cell where we had two containers, two different solutions. No, in here we've got a single solution, and now what we're going to do is we're going to pass a current through these two. So a current means that we're going to have a power source. Here we connect some sort of power source. Now in this case this is the positive end and that is the negative end. Now what is going to happen here is that electrons are going to be supplied by the negative side of our cell or our battery. So electrons are going to flow in this direction, and that is going to cause this electrode to receive electrons. Okay, so this electrode is made out of some sort of substance, and as a result this electrode is going to become negatively charged. It is going to be able to donate electrons into the system. So what color are we going to see nicely? Blue, doubtful, pink, oh, maybe none of the colors are going to look very clear on here, but it's going to donate electrons at this point. Now if it donates electrons at this point, the positively charged cations will tend to come here and collect for itself electrons in order to become a pure substance. It is negatively charged, so it will come and receive the positive charges. As it is receiving positive charges, it will somehow produce whatever X is. So we will have X positives, will get electrons and then produce X's. Now if it wasn't for the fact that there was another electrode connected here, then this would be a reversible reaction, because the moment that it receives an electron, the solution will become, it will have received electrons, so the solution itself would become negatively charged and then start repelling electrons and not accepting electrons anymore. But now what happens is that the anions because they are negatively charged, and on this side of my electron or of the outside of my circuits, electrons are coming from this point, being attracted to the positive charges. So this becomes a positively charged electron. This is a negatively charged electron. The positively charged electron collects now the negative ions. So the negative ions are joining to this side, and what happens here is that the negatively charged ion is donating its electrons to this electrode. So it's losing electrons, and therefore it is producing Y substance. Now this could be a gas, or it could be a solid. Okay, so this could be a gas, or it could be a solid. Now if it was a gas, then we would see little bubbles forming. I wonder if I'm going to be able to draw little bubbles. I think I might. Let's see. What if I try doing this? Okay, little bubbles forming on here. Try again. No, I can't draw bubbles. Okay, there you go. Little bubbles might be forming here if it is a gas, releasing that gas into the air and can be caught somehow. If, however, it is a solid, let's try a solid to be, what color shall we choose? A red solid. Now if using red there, what about a yellow solid? If it forms a solid, let's say Y is a solid, then we would start having a coat forming around this bar as the solid is forming here, where it's donating electrons. Okay, which is quite possible when I donate electrons to find solids, because usually the guys donating solids are the metals forming a little metal layer here. This is called electrolysis. And in the next couple of videos, I will look at the electrolysis of a few electrolytic solutions. So we will have electrolysis of compound X, Y. Okay. Excellent. So this was very theoretical, makes little to no sense if we don't have actual elements here. So let's just quickly name the electrodes. Which one is the anode and the cathode? Remember, the anode is the one where the current flows into the electrolytic solution. Current is in the opposite direction as electron flow, and so I don't like the definition of current, so I like to look at the anode being the one that donates electrons, or where the electrons are flowing away from it in the outside. So this is the anode. In this case, the anode is negatively charged. The cathode is the one that receives. So the cathode in this case is receiving, and let's see which one is being oxidized and which one is being in this case, and we'll look at each case specifically. Don't go and generalize it, guys, and say, okay, at the anode we always have what is this, losing electrons, so oxidation. Maybe it's like that, but go and look at every scenario, every electrolysis at its own, and name the things as you understand the whole process that's happening here. But this, for example, is reduction, because we get gaining electrons. So reduction we see happen at the cathode, because that's where the electrons were being donated, and oxidation is where the electrons are being reduction is where the compound donates electrons. The cathode donates electrons to compound X to reduce the compound. Okay, so thank you very much for watching. I think that's said enough about the introduction to electrolytic cells. In the next couple of videos, we'll look at specifically electrolysis. For example, the electrolysis of copper sulfate and water. We'll see you in those videos. Goodbye.